And I'm going to break it down into 3 sections. So why, as in what is the value of that? Why would you want to take the data that you're sitting on in your company at the moment and put that into a knowledge graph? So what would that knowledge graph look like? What's the technologies that it's based on? And then a how, where it gets a bit more technical, where we can kind of go into some of the details about how you'd actually do it. So in the why section, I'm going to put forward 3 arguments, which I think once you take them together, create an inescapable logic. You guys may think differently, but as is in the media very much at the moment, although really this thing has been happening and building slowly up, AI is on its way. The AI wave is coming in, and big breakthroughs are being made with it. And if your company exists within a knowledge-intensive industry, so if you're in kind of finance or medicine or anything where a lot of your decisions are based upon data, then the starting guns have fired. Some of your competitors are already out of the blocks. You have to really think seriously about engaging with the AI revolution. Otherwise, I don't know how many of you here are old enough to remember Blockbuster Video, but they failed to engage with the internet revolution, which was the previous one that came before, and their history now. The next argument that I would put to you, so the first is AI is coming, and you need to engage with it. The second is that you can't do machine learning algorithms or AI of any serious sort without clean, connected and consolidated data. If you put rubbish in, you're going to get rubbish out. And most of the time spent for the data scientists, sadly, is actually upon kind of wrangling and cleaning the data and getting it into the shape that you can do your clever algorithms on. And if you're talking about your company that you're running, the data assets that you're sitting on top, they're like a kind of gold mine of information that exists there. They represent, in a virtual sense, what your company is and what your business is about. But you've got to get that data into shape in order to be able to use it. And when you talk about getting that data into shape, really, again, AI requires huge amounts of data. So what we're talking about here is actually realizing all of your company's data. So every single piece of data that your company currently is sitting on top of in its various different databases, make all of that available and connect it all up so that you can start doing the clever stuff on it. Now, the argument that I would put here is that so far these data integration projects have all relied upon centralized way of doing that. You've got a central data team, you try a data warehouse. All of these projects are kind of top-down efforts, and you're never going to be able to realize all of the data assets that you're currently sitting on top of by taking a centralized approach to the problem. And this is where we look to the web. And you think about a decentralized approach. So I guess put it this way: imagine trying to do the World Wide Web, where there was a centralized web team that kind of took all of the books and pamphlets and turned them into HTML and connected them to other people's. The web couldn't have worked that way. The web worked the way it worked because it was distributed. Okay, so what are we talking about then with a corporate knowledge graph? What would that look like if it's going to kind of answer those 3 questions that are put there together? Okay, so to understand a kind of linked data corporate knowledge graph, you have to base that you have to sort of put a foundation of that knowledge into an understanding of the web which exists today, and in particular 3 technologies that I'd like to highlight. So the first technology is HTML. So with HTML, what you can do is you can take a booklet, a pamphlet, information about your company, any information, and you can convert it into the standard of HTML so that any browser will be able to render it and understand it. The next web technology is the HTTP web server. So I can now take my HTML page and I can give that HTML page a unique URL and make that available on an HTTP web server. So that means that you can go into your internet browser, you can put that unique URL in, and then because it's coming back in HTML, which is a standard that all browsers understand, that document will display. The third technology is the HTTP hyperlink. So here I've got a document about the Eiffel Tower, which is telling me all about the Eiffel Tower. And then here is the architect who built it. So each one's got a unique URL. And because this one links to this one, I put a HTTP hyperlink between the two. They can be sitting on separate web servers, but I'm able to surf the web and click on the hyperlinks and go from one to the other. So linked data is the same thing, only now we're not talking about documents, we're dropping down a level, and we're talking about the entities that those documents are related to. So I'll run through three technologies that are there. So first of all, we've got RDF. So RDF is just like HTML, only it's for data. So HTML lets you display a document that any browser can read. RDF gives you the data, that a standard format for your data. So in this case, we're going to talk about the entity, the Eiffel Tower, and we're going to give its height, the date it was opened, and various other pieces of information. The next piece of technology is an already existing piece of technology, which is the HTTP web server. So you take your RDF and you publish that on your HTTP web server. And the third is already an existing piece of technology, which is the HTTP hyperlink. So the HTTP hyperlink, here's two separate pieces of information in the standard format of RDF, both with their unique URLs made available on HTTP web servers. And because the architect of the Eiffel Tower is this guy, I can now go through that and get all the data about Stephen. So out on the web, the big corporates, the big tech companies are basically using linked data plus proprietary tools to go about building these knowledge graphs, these graphs of data. So what they do is they kind of take all of these entities. So here we saw the Eiffel Tower and Stephen Sylvestre, the architect for that. If you pump one of those things into Google, then you'll get the information box, which will pop up on the side with the kind of stuff that Google knows about it. So Facebook, we've got Open Graph, and Amazon has similar stuff going on inside it. So the idea being that you create your entities, and then you can send your machine learning algorithms, you can do feature extraction, you can basically send them crawling around this web of information and come back with insights. So what I put to you here is, okay, in a company, pretty much every company now has an intranet. So you take the standards of the web, the HTML, etc., etc. You've got your documents which are sitting behind your corporate firewall. They're yours, they're private. But you reuse the standards of the web to build yourself an intranet. And pretty much everyone's done that because it's a useful thing to do. So what I'm saying is, well, why not do that using the same standards of RDF and create yourself like a little corporate knowledge graph of your stuff. You get to reuse the same tech stack, which is already being kind of built out there on the web, and you start to link together now not your documents, but actually the data that your company is sitting on top of. And what this would result in, if you did this, would be your own kind of corporate knowledge graph. So each entity would get its own unique URL. You would record all of the data about that given entity, and where one entity links to another entity, you would have an HTTP hyperlink between the two. And as this built up within your organization, all of your data assets, which are currently kind of locked away into separate silos and separate databases, get realized up to the top. Okay, so dropping in now to the how of this. So the first thing to start with is the understanding that what you're doing is you're giving each and every single data entity within your organization a unique URL. That's, in RDF terms, it's URI, but let's just say URL, the thing that you tap into a browser. So it doesn't matter what it is. Each and every entity needs to have a resolvable URI, a resolvable URL that if you go and hit that address, then back will come the data related to that given item. And then across your organization, and in large organizations, we can be talking about thousands and thousands of separate siloed data systems. All that you have to do is, first of all, convert your data into RDF, and then publish that data. So here at this point, there's various tools which are sitting out there. If you like programming in Java, then you've got RDF for J or Jenna. If you're in .NET, there's RDF.NET. If you're doing Python, there's RDF lib. There's kind of, what I'm telling you is that there's a plethora of tools already out there that you can kind of take. You don't have to reinvent the wheel here. Let's take a database example. Every row in the database of a given table, what I do is, like, so this is the table, it's trade. This is the primary key of that that given row. And then every cell in there becomes like an RDF property. I take that, and using an HTTP web server, so again, that's just technology that you can go and grab off anywhere. If you're in Java, you just new up a Jetty server, or you're .NET, then like, you know, MVC or WCF. Again, this technology is kind of plug and play technology. You can go and grab that technology, and you make this RDF available on your web server. But where information in your sales DB, and then, so it doesn't matter whether it's an Excel spreadsheet or it's JSON, like literally any data, you can stick one of these publishers over the top of it, a little web server publisher over the top of it. You make the data available in RDF, doesn't matter what the data is. And then where one application links to another application, so where I've got a sales record here, and then information in the HR system about people here, this sale was done by this person. This person, Bob, has got a unique URL, so I just do a link to that URL. So across the company's architecture, you can begin to create this distributed graph. So you could imagine a situation, like a hypothetical situation, where like a CEO of a big company could say, right, I'm really bought into this. I want everybody to take one of their developers off a given application, and for the next month, your project is to surface your data and to link to any other system that you know that you're linked to. That effort could be distributed in a way that you could never do with like a kind of relational database. The human effort could be distributed. And the result sitting over the top of it, your existing infrastructure stays exactly the same, but the result sitting over the top of it is this searchable graph of connected data. And as I was saying there, as one system links to another system, you form these HTTP right, when I publish my RDF off, I'll call out to the lookup service, pass in the QSEP, get the company's unique URI for that, and that's what I'm going to publish out when I publish my data. Then the next part is linked data consumers. So ideally, in an ideal world, you would just be able to go off and query against this graph and get really good performance off of querying this distributed graph that's across your whole company. But state of the art is not there now. Maybe it never will be. So the solution that I currently advocate is an idea of different linked data consumers. So on the web, you don't load the whole of the web into your browser. You just load the pages that you're interested in. You maybe cache some of it. The equivalent to the browser in the linked data intranet scenario is something called a triple store. So the triple store is like a database that understands the linked data that's being published by the publishers. And a given function, a given department will not need to consume the whole of your company's corporate intranet into it. It will need a small subset of that. So the hard work of data integration, that's done out here. That's done by the publishers. So the publishers are cleaning up their data. They're linking to other people. Each application is doing that. That's created you this resource, which is your kind of corporate knowledge graph. But then at the level of the individual department who've got a particular business case to follow, what they do now is they go and grab the parts of this graph that they're interested in, and they store that down in the triple store, and that's kind of happening on an automatic basis. It's just kind of always pulling information out of the graph and it's loading it into the triple store. And then once you've got it into the triple store, you're able to write these very structured queries in a language called Sparkle. And again, what I would recommend is that you basically save these queries. So basically a given you'll be servicing a given desk, you've pulled the information in for them, and then they'll begin asking you for questions against that. You know, what bonds are in this ETF, or what salespeople were my best salespeople. These will be the kind of use cases that come out. And for each one of those use cases, you answer it by writing a Sparkle query and saving that Sparkle query down. On top of that, you can use a standard called Spin, which is gaining a lot of adoption now. And what that lets you do is that lets you parameterize those queries. So I could pass, my question could be something like, who's the top salesman in a given department? And then I would pass the department in as a parameter. So that basically lets you kind of reuse these library of queries. And these build up really, really fast. And once you've got this library of queries, that then lets you start building out your ontology, because the queries represent your use case, the information that your users are interested in of this kind of wide, massive graph of data. You've now got particular stuff that it's kind of honing in on, and that narrows your space down. So you then begin working on the definitions and the kind of schema of the graph. It's kind of like metadata. And all of that together kind of creates you this architecture for your own corporate knowledge graph. So on one level, all of your applications, so over your current data assets, which get to stay exactly where they are, doesn't matter whether they're in a mainframe, an Oracle database, Excel spreadsheets, whatever the relevant data is, each one gets a data publisher over the top of it, publishing in our RDF, and then links to other applications. This creates you this creates you your kind of web of data, your corporate knowledge graph. And then for individual business functions, you're sucking down a subset of this, which you write queries over, which service directly to your users, and you run your kind of machine learning and just general algorithms over the top. Furthermore, what you do is from these queries, you establish what the key data is, and you begin learning and building out your kind of schema and ontology, and that then feeds in to make this experience richer for the end users. And yeah, that about sums up how you could go about building your own corporate knowledge graph. I'll take any questions if anybody